look at two application problems. So in example 4, we're looking at two forces in the vertical plane acting on an object. We've got one force of 6.85 pounds acting to the right at an angle 18% above the horizontal. The other force acts to the right but at an angle of 51.5 degrees below the horizontal, and we want to find the resultant. We want to find what happens when we add these two vectors together. So the first thing you should probably do is just imagine what's going on here. I like to draw a picture. And here we have this one vector of 6.85, and we know that it's 18 degrees above the horizontal. And this other force is below the horizontal, so that's negative 51.5, and its magnitude was 7.44. So we need to get the x components of these. 6.85 times cosine of 18 degrees is 6.515. The y component, 6.85 times sine of 18 degrees is 2.117. Our x component of the other vector, we have 7.44 times cosine of negative 51.5. That is 4.632. And the y component of that vector, 7.44 times sine of negative 51.5 degrees. And that gives us negative 5.823. So what do we get when we add these together? X is 6.515 plus 4.632 adds up to be 11.147. Our result for y ends up being 2.117 plus negative 5.823, and we get a negative 3.706. So r has to be the square root of those two squared values added together. And we haven't had a negative under this radical in a little while. Remember, when you square a negative, you have to put it in parentheses or the calculator will give you the wrong answer. You should get 11.7 out of this, and our units in this case for the magnitude is going to be in pounds, and our angle will do inverse tangent of our y value over our x value, and that's going to give us negative 3.706 divided by 11.147, and we get negative 18.39 degrees. Now, on these problems, though, we do need to check to make sure that our angle is in the right quadrant. So I want you to look at these two vectors. We have a 6.85 at an 18 degree, and then a 7.44 at a negative 51.5 degree. Where do you think these two vectors should end up when we combine them? Well, hopefully you would understand that we end up in the fourth quadrant because that 7.44 vector is going to overpower the 6.85 vector. And so we should end up with something in the fourth quadrant. Because of the limitations of our angles, when you do your inverse trig functions, it's only going to give you one value. But if you remember from our discussion of reference angles, you're always going to have two angles in any situation where they have the same trig value. So tangent being negative would have happened in both the second and the fourth quadrant. So negative 18.39 is the value in the fourth quadrant, but what if our result was supposed to be in the second quadrant? This inverse tangent function will never give you the answer in the second quadrant. And so when that's the case, you're going to have to use those reference triangles. So I'm going to show you in example 5 when that happens. So I want you to look at example 5. Before we even do anything, which quadrant is the answer going to be in? Hopefully by looking at these two pictures, you realize that the answer is going to be in quadrant 2. And our tangent function will not give us the right answer. It'll only give us answers in quadrant 1 or quadrant 4. So if we get an answer that needs to be in quadrant 2, we're going to have to use the reference angle with that quadrant 4. And then if we get an answer that is supposed to be in quadrant 3, the calculator is going to give it in 1. That's just a limitation of the calculator. It's not going to give you 2 answers. So if you need your answer to be in quadrant 3, then you're going to have to do a reference triangle or reference angle with 1. The answer that you get in quadrant 1. But I am going to give you just a little trick to get these answers. If you need to go from quadrant 4, so if you get a negative answer and you need to go to quadrant 2, just add 180 degrees. It'll get you there. It's going to give you that same angle. If you're in quadrant 3 and that means that you had a positive answer, the answer is going to be our answer is going to be in quadrant 1, but we need it to be in quadrant 3. Again, just add 180 degrees. This is kind of a shortcut for you, but you do have to pay attention to where the answer is going to end up. Inverse tangent will only give you answers in quadrant 1 and quadrant 4. If you need it to be in 2 or in 3, you're going to have to add 180 to whatever result that you get. All right, so now let's actually do this. We need our x components, our y components. So let's get those in. We have 62.0 times cosine of 45 degrees. That is equal to 43.8. Our y component, 62 times sine of 45 degrees, is also 43.8. Then for the second vector, now I want you to pay attention. We have 60 degrees from the west direction, but that is not how we describe an angle. We describe an angle from the starting positive x value. So how would we get that missing angle? Well, it's 180 minus 60. Okay, we want the other part. That 60 degree does not help us with how we handle our angles. We're actually looking at 120 for the way that we put this in the calculator. So the magnitude here is 205. We have cosine of 120 degrees, and that gives us negative 102.5. And then y, 205 times sine of 120 degrees, and we're looking at 177.5. What's the result for the x? Negative 58.7. What's the result for the y? It is 221.3. So overall, this vector is going to have negative 58.7 squared plus 221.3 squared, and that is going to equal about 229. Our angle here is going to equal the inverse tangent of the y, 221.3, divided by our x, 58.7. And our angle here that we get is negative 75.1 degrees. That is an answer in quadrant 4, and we don't want that. So what we need to do is we need to add 180 degrees. That's going to put that same angle in quadrant 2. So really, the angle that we want is 104.9 degrees. So just be careful when you are doing these problems. The answers are often going to give you an answer that is not where it's supposed to be, but it's really easy to fix this. And just remember, to move into the other quadrant, you're going to add 180 degrees, or you can just change how you're thinking of this. The angle, with that being negative 75.1, that's in the east direction, but really we can describe that, we could do 104.9 degrees for that angle, or you could just think of this, if we're going negative 75.1 here, it would be the same reference angle. And so if we want to use our cardinal directions, we could always say 75.1 degrees north of west. So I don't want it to get any more complicated than it already is, because we've already complicated this problem quite a bit. Most of your questions won't have this kind of thing in them. But just be mindful of when you do have to do a little tweaking to your final answer.